Hello and welcome to Global Azure 2022. And this is now a true global event. It is about 500 presentations going on now. And it's spread over 6 continents. And here in Skåne we will have an exciting program today. It will first be Goran Vuksic who will be speaking about synthetic data. And then we have a short break. And we will have another AI presentation by Peter Heiberg. And then we'll take some lunch and be offline. And then in the afternoon, we'll be talking about monitoring Power BI, which can be a really difficult task. So that will be very helpful with an explanation how to set that up. And we are Azure Skåne. And how many are new here? How many have never been here before? Okay. An extra welcome to you. And Azure Skåne, that is about learning things. It's about networking and, of course, to have fun. And we are over 1,000 members. We had bigger audiences before the COVID times. It was a little bit more difficult to arrange things for 2 years, but now I think we are building up the physical audience again. And everyone is really welcome here, regardless of your previous knowledge of Azure and technology. And this is the Azure Skåne crew. It is me, Johan, and I'm an independent consulting running my own company. And then we have Michael, who is he's working for Microsoft as what's called a success cloud solution architect. Yeah. And then we have Magnus Mortesson, who's a Microsoft regional director. And since we have people online viewing this, and not everyone is aware of what Skåne is, let's just talk a little bit about us. So Skåne, that is this little part here on the screen in South Sweden. And we are famous for some things, like this very large building, the Turning Show, which is one of the highest living buildings in Europe. And we have this amazing bridge. It's a really beautiful sight when you drive over it. And you can see it's also a tunnel there at the end. And we have the world's best soccer player, at least according to himself. And if you like strong drinks, you have the Absolute Vodka brand. I hope it's still manufactured here, I don't know, but it comes from Skåne. And we have a really massive gaming development business here in Skåne as well, making some really big titles. So just a short question about the audience here, who you are. How many of you are working with Azure today? Everyone. Yeah, but that's actually changed a little bit since the start, because a couple of years ago, people were starting to look into Azure, but they were still not working, but that's nice. So how many of you are developers? Okay, yeah. And how many of you are working with machine learning, AI? Okay, yeah. And how many of you are working more with infrastructure? Yeah, okay, so that's a majority here today. So anyway, very welcome all of you. And now make sure we are heard. So anything you see here, you are very welcome to share it on Facebook, Twitter, or any place. It's just very nice if we can make a footprint in social media today. And then I also wish to say a big thank you to Foo Café for sponsoring us, hosting us, providing the venue and food and everything. Now Michael has disappeared, but thank you, Michael. I also encourage you to join our Discord channel. I'll move aside so you can see the QR code here. This is the address, and you'll find a lot of useful stuff being posted there regularly. So that is the place between our meetings to get updated and stay in touch. And I also wish to promote the next event already. We'll talk about Azure Analytics end-to-end, a complete solution based on Azure Data Factory, Databricks, Azure Storage, Key Vault, etc. So we will have a presentation on June the 8th. That will be the last presentation before the summer. And with that, I say a really big welcome to Goran Vuksic. Welcome.
Okay. Just a second. Yeah, that. Okay. You sure? Yeah, maybe not. It detected it's connected, but not switching anything there. I have another one. Maybe I can try that one. Yay! All right. Hello. So today we will talk about synthetic data, and as I say, from 3D model all the way to AI on the edge. I'll show you some quick examples, even you haven't worked with custom vision training. I'll show you some basic examples, and then we slowly deep dive into this topic, go into more details about it with some cool examples and hopefully demo that works live. So my name is Goran Vuksic. I work as engineering manager at Pandora. I am Microsoft AI MVP, which is a recognition that comes for holding a lot of sessions out there and on different topics, but mostly around AI. My direct messages are always open. Feel free to connect on Twitter, on LinkedIn. You can find me over there. Some topics I mostly spam about is AI, IoT, Azure, and so on. All right, so computer vision, something that we see nowadays more and more, I would say, in different applications and different places. Like our computers are able to see, are able to recognize objects or persons in pictures and videos and so on. And we use it in many different places, and some most common tasks that we use with the computer vision is to do some kind of image classification. Like if you search online for some basic examples, you will first find, okay, is this a cat or dog on the picture, right? And then it becomes more and more complicated. We also do object detection, trying to find specific object in the picture. This is what we will look into today. And some other common tasks is this optical character recognition, being able to read the text, facial recognition, pose estimation, and so on. Like there is many tasks that AI is capable nowadays to do. And I think it's pretty exciting and pretty cool, like where it got, and there is a lot of cool services out there on Azure you can try out and easily plug it into your existing applications. So we said we will talk about object detection, and this thing will go off, I assume. Yeah. Okay. So with object detections, we are trying to identify specific object in the picture. For example, if we use AI to detect glasses on this picture, we would get some results like this. So basically, on the picture, we get the bounding box showing, okay, glasses are found exactly here, right? This is what our computer is able to see. And it will give us some value like, okay, what is the position of that bounding box? What's the width and height? And yeah, some other parameters usually. How certain model is that those are actually the glasses. As you can see, those glasses are covered on the specific areas. So, like how sure it is those are that detection is correct. If you use some standard computer vision, you could also detect there is a dog in this picture, there is probably a laptop in the background, even though it's blurred, and so on, right? So those are some standard detections and something you can use different models that are out there already pre-trained with different categories and use them basically out of the box. So you just send your picture to API, get the result back. If you want to detect something custom, there is a service called Azure Custom Vision. For example, if you would like to detect this Batman, Lego Batman minifigure, then you would probably need to use this service because this is not some standard object that we train AI for to be recognized. And maybe in industry you have some specific product that you would like to recognize. So it's not something standard like a chair or table or laptop. You want to recognize exactly that product, then you need to train your model. You can use custom vision, which is a nice web wrapper around it, where you just upload pictures and train the model and get results out. You can use that model, or you can use API once you publish it. So we talk about custom detection, and I will show you one project that I did some long time ago. Project is very chewy, trying to find this Lego minifigure on the board with the use of AI, right? So first we need to train the AI to be able to recognize our Chewbacca, and then we try to find it, okay, where it is over there. So how we do it in the custom vision, we create new project, we give it some name, we can add the description, define the resource group, choose the project types. Is it classification or is it object detection? We said classification will tell you, okay, is this picture cat or dog, right? With object detection, we are getting bounding box, searching for object in a picture. It's exactly over there. We use the object detection and we define domain like general over here. There are some other domains that, like logos or products on shelves that you could use. So how the process looks like. We need to prepare images first. We need to take that Lego minifigure, take a lot of pictures of it, and upload the pictures to custom vision. We need to tag them, we need to train the model, and then we can test the model, right? So how it looks like, first we upload pictures. Over here you can see that minifigure. I used the Lego catalog as a background, so I'm switching pages, so there is some variations in the backgrounds for AI to be able to detect it easier. Minimum number of pictures you can use is 15. If you want to train in custom vision, over here I'm just adding 17 of them, and that is really low number of pictures. So what we need to do once we upload them, we need to open each one of those pictures and tag, okay, our Chewie is exactly here. So we are creating some label and tagging each one of those pictures. It's a manual process, it takes time. If you tried it out, you know it's the pain. You train the model, and now you can, over here immediately in the interface, do the quick test and try to figure out how well your model works. First run, it doesn't work well. It has some detections, probability 20%. It haven't found Chewbacca in the picture. So what you need to do now is you actually need to go back and you need to prepare more images, right? You need to take more pictures, you need to upload them, you need to tag them, and then you train the model and test it again. With another test, now we got 40.8%. It is Chewbacca over here, right? And you can also see that is the third iteration. So I already added in second iteration even more pictures, third iteration even more, to be able to get some probability over here, which is still way too low, right? So if we want to do this, usually you will find yourself here in this loop that is super time consuming. You are taking pictures, you are uploading them and tagging them, right? The training model, it's one click of a button, and then testing, okay, you can send via the interface that picture and try it out. Or you could, you could publish the model and try via the API. So when something is repetitive and boring, usually there are ways for automation, right, to make it whole process more smoother. And here we touch upon the topic of synthetic data. And usually this synthetic data is generated from different simulations or algorithms, and it actually provides us inexpensive alternative to real-world data. So we can generate pictures and actually use those generated pictures to train the models. And there's many benefits of the synthetic data. For sure, it will shorten the time for this data collection and tagging. You know, repeating this process of taking pictures and then tagging them, it takes really long. So it will also minimize the cost for data collection, can reduce bias in your data. For example, like if I would like to detect my watch, right? Watches come with many different bracers, like in different colors. So maybe it's white, maybe it's green, I don't know. So I need to use all those kind of pictures to be able to train my model. Sometimes I'm not able to do that with the product I have at the moment in my hand, right? So with synthetic data, I could do a lot of variations. And yeah, some other examples with bias like GDPR. It's a good thing, but it's a big issue for AI. And something like we see that in China, where there are no rules regarding the data training, they train their models and being able to achieve maybe more than we need to comply to some rules, and then it's, yeah, you need to be sure to find the right training data. And in the end, being able to automate this and use synthetic data will allow you to get more accurate AI detections. Synthetic data is not something I invented, far away from it. Synthetic data is a huge topic out there. There are several nice researches out there that you can take a look. Over here is one picture from the Gartner research. What they are saying is basically like we are somewhere here today. We are using synthetic data a bit, but like by 2030, it is expected that synthetic data use will be like 3 or 4 more times used than the real data. And I fully believe, as they said, it is the future of AI. We will more and more run different simulations. And I will show you some examples what is possible today. And with those simulations, we will use results to train our models. So how we can achieve that? One way to do it is to use Unity perception. Unity is a tool that is mainly used to create games. I don't know, have you tried it out? It supports C#, pretty easy to start. You place some 3D models, attach scripts to them, and then you can make the easily some character run and collect coins and things like that. Pretty easy to use, and environment for Unity, like you do everything in a 3D environment, so you have your camera in 3D, you can place some objects and such. What you see over here is this perception package that allows you to generate synthetic data. And what you can do with it is basically you take your product, some product, 3D model of it, right? You throw it in, then you use different products in the background and render pictures out of it. And then you immediately know, okay, maybe this is the product I'm looking for, and we get variety in the backgrounds. We can also rotate this product to get it from different angles and such. Here is a quick preview how it looks in Unity. When it's rendering different products, you can see over here how they are shuffled, right? And we get different images as output. We can use this to train the model and yeah, improve its accuracy, or even train it from the scratch. Like, important is that you use realistic 3D model when you do that. Some other tools out there that you could use is Nvidia Omniverse Replicator. What Nvidia focused on is self-driving robots and solving some use cases, mostly like in an industry, in a warehouse and such. You've probably seen some videos how Amazon warehouse looks like, right? Everything's fully automated, those robots go around and things like that. So how we train those robots? We can use the real data from the warehouse, or we could generate it with this Nvidia thingy and try to simulate the warehouse, or also recognize some other vehicles in warehouse. And as an example over here, you can see one forklift. This is how Replicator works. So you can apply, like, use different models. You can apply different textures to them. So they don't have always to be how it looks for real. You can rotate them in any direction, right? And then you can also combine it with different backgrounds, different objects. And as you can probably see on some pictures, it is cut off, mixed with the other objects for AI to be able to say, okay, this is how it looks like. It also uses the different types of lightnings, so trying to simulate the real world out there. You know, you don't always have the full object in the scene. It's pretty cool, not so user-friendly yet if you're going to try it, but everything's out there, like you can test it out. Also, what Nvidia just released 2 weeks ago, actually, they open source the Nerf. You can find it on the GitHub if you want, and this Nerf is capable of rendering 3D scene from 2D pictures. So, for example, we have few pictures like this, and with Nerf, we are able to do this. This is pretty amazing, right? It's really cool, and I think they released it like 2 weeks ago. So a week ago at evening, I was reading something about it, and I was, yeah, I need to try this. And what will I do? I'll go to forest and you know, stand in forest and see how it renders around myself with the trees and everything. So I woke up next day 6:30 and told my wife, like, we need to go to forest to to take some pictures. And she was like, what have you dreamt like this night? It's what are those ideas? I tried it out, and works pretty good. spoiler, not me in a forest. This is how it looks the interface when you're rendering that. You need a pretty strong graphic card. My graphic card is in a range of, I actually bought it for my son's computer. It was something like 5,000 Swedish. And the graphic card they were rendering the example on is 20,000. So, you know, range of the graphic cards are expensive nowadays. So I was able to render the scene, but I wasn't able to export it out to show you how it looks. But it's pretty cool. Interface looks like this, and basically it's instantly rendering, and it takes like 2 minutes to be able to get the scene out. So here are some pictures, like they have some Lego toy, and you can also try their examples, and then quickly renders from different sides, and you are able to rotate this and such. The thing is, this is pretty new, and just like came out there, and it needs a lot of improvements before we will actually be able to get 3D model out. You can get it out, but it's not so good. Like it looks nice when you run it in such, but if you want the 3D model, it's something else. So over here you can see another example. Someone took the pictures around the lab, right, and decided to render it with instant Nerf. Over here, yeah, why Nvidia uses the dead animal in demos, I don't know, but it's the fact. In those 2 examples, you will see on the webpage if you try it out. And yeah, I think that Fox uses like something like 50 images or something like that, and being able to get it in 3D, that's really, really impressive. For this example, I'm not sure, but like between 100 and 150 images are needed if you want to make something like this. Again, I strongly recommend like a strong graphic card. Yeah, so are there some other ways to generate the synthetic data, and can we create it on our own programmatically? Yes, for sure. And that's something I will show you. And for this purpose, I will use JavaScript, which is the most used programming language out there. Most popular is Python at the moment. It was JavaScript for a long time. And reason for that is I want to show you how it can be easily done in a browser. Because my take on it, if it works in browser, it can work anywhere. Then you can use any type of application and do the same, following the same logic. And for this purpose, I will use 3JS. It's one nice JavaScript library that allows you to load 3D objects into the browser and render them in the browser with WebGL. Yeah, source code is on GitHub. You can find it on the website, 3js.org, or go directly to the GitHub over there. So, what's the presentation without the terminal? All right, give me a second. There we are. Okay, so I will just run it locally, and then I'll switch to my browser. This is a bit of a problem because it's not. I'll try to do it like this. So this is 3JS. If you go to their landing page, 3js.org, you will see a lot of examples over there. Pretty cool things that people do, like in the browser with 3D objects. And over here you have their official examples. And in the examples, for example, here, first one that we load is some 3D object. You can see it's also animated. And yeah, you can rotate it around, and I think performance is pretty amazing. You know, works in a browser. It just works. Supports different kind of different kind of 3D objects. Even though if you worked with 3D, you know there's way too many different formats out there, and they can show you some pretty cool stuff what you can do with it, and especially regarding some reflections and lightnings and things like that. So it's pretty nice demos, and pretty useful stuff actually if you are building the real scene, right? And yeah, you can spend probably a few hours going through all of those, but like you can see over here some kind of fog rendered and so on. Really nice, and something that comes out of the box. And I'll switch to Visual Studio Code to show you actually how it looks. Over here I have a standard example that's edited just a bit. And the idea is I have this Lego R2D2. Basically comes in many Star Wars sets. You can find that. I'll use 3D model of it and train the model to be able to recognize it, right? So without use of any real pictures. I'll show you how it's done. So this is how the code looks like. It's based on the template that's called FBX loader. That's the format for this 3D model. We import some stuff. We define some variables. As I said, there's standard examples, so I will not explain line by line. I'll explain the bigger chunks. We need some container on the web page where we want to render it. In that container, we need a camera. Like any 3D scene needs a camera that looks at something. So we create the camera and we create the scene. We will create lights on that scene, so it's realistic. It will drop the shadows. In the scene, we don't want it this object to be flying around. We will create some kind of ground. So we will create just one simple 2D mesh and add a grid to it to be able to see, okay, this is a ground. And then we load our model, R2D2, over here. We will enable it to cast and receive shadows. So we have lighting on that scene, so we will see it, it's dropping the shadows. I'll turn this on later, and we add the object to the scene. So let's take a look how it looks like. I started 3JS in terminal, so now it's loaded, and I have the 3D model of my R2D2. I can rotate it around, take a look from different angles, zoom in, out. You can see it's casting the shadow over there, so it's pretty much, yeah, some realistic scene, but we'll make it more realistic. First thing we need to do is we need to apply some textures to R2D2. And the 3D object itself consists of two parts, the head and the body. So we have two textures that are loaded, and as you can see, there is a child of that body that is called head and the body, and we apply appropriate texture to it. Okay, so if I just save this, go back to my browser, if I refresh it, we have R2D2, right? And it's pretty similar to the real object, right? Whole point of synthetic data is to use as realistic models as possible. And okay, so what we want to do now is maybe to use some kind of background. Difference in my approach here, and if you go with Unity and Nvidia Omniverse, they will request you to have a 3D scene modeled. And over here, I'm using the backgrounds just a static 2D backgrounds. That background is downloaded from the official Star Wars wallpapers, right? That's what I'm using over here. I will add it to my scene, but before that, I will disable ground and grid that we have, so it will look a bit better. That was ground. This is grid. So if I go back, I get some R2D2 flying there in a space. We could say, okay, it's not standing on the ground. But for AI, that's not important. For AI, it's important, like this environment where it's rendered, to be able to say, okay, this is R2D2, but this is not, right? And when we have it here on the scene, we can also calculate the bounding box where exactly it is on the scene, where it is positioned. And okay, so if we want to generate some synthetic data, I guess it will not be the case that camera is always looking from this side, as it is now. So we could do something cool with it. We could turn on one small function that will do the camera rotation. As a result, we will have that R2D2 flying in a space. And now we could take the screenshots and get the rendering like from all different angles. Depends how we rotate our camera. Mine is at the moment going back and forward. But for example, it in this case shows the bottom, right? And that's usually what we forget when we take the pictures of some object. Yeah, I need it from all angles. I need it from top, from bottom, and such. So this is pretty cool. We got it in browser. We can also shuffle the backgrounds. You'll see an example soon. Shuffle the backgrounds and get some variety of it. We could apply the different lighting effects. Yeah, depends on your scene. It could also have some reflections and such. Depends what you're rendering and what you're after. Okay, getting back to here to our presentation. So we have that model, and we want to take screenshots of it. Another pretty cool library from Microsoft Playwright, the framework for web testing and automation. It works like cross-browser, cross-platform, yeah, different languages you can test the mobile web. If you do some kind of testing or have a need for testing of web pages, I strongly suggest to check it out because it's pretty amazing. And I'll just show you code over here in few lines of code. We can go to our page. This is page that I was displaying like R2D2. We can give it a few seconds to render stuff initially, and then we can save the screenshot of that page, right? So we get the picture. Then you can write one loop, change the backgrounds, put the different pictures in it, render it from on many different Star Wars backgrounds in many different angles, and get it into custom vision. And you can immediately over here run like a quick test to see how it works. You can expose it over the API, or one thing you can also do if you don't like custom vision, want to do something else, you can export this model and use it with TensorFlow, for example. So there are many possibilities over here, and yeah, then you take your model and you test it elsewhere. Where I will test this model, we'll test it at the edge. And this is like where AI is going nowadays. Earlier, we were trying to upload everything to the cloud and process it over there. Works up to a certain point. But what we have nowadays, like just imagine some smart car, right? It has so many sensors, so many data. Now imagine that it is a self-driving car, so it needs the camera feeds. It's not just front and back, it's also the sides, rear mirrors, and so on. So all this data, like, depends where you try to find the answer, but what I found is between 10 and 20 terabytes of data is produced by one self-driving car in 1 hour. So imagine you need to stream this data to the cloud to process it over there. And now imagine that you have a fleet of those cars because you have a modern delivery service, or you have some new type of Uber or whatever it is, right? So there is no such bandwidth that can support that, right? We need to be able to process that data at the spot, at the edge, in that car, and only upload data points to the cloud. And then we use that data points to, build some insights and so on. So this intelligence is going to the edge, and last year, Microsoft released pretty cool device called Azure Percept. That was, I think, in April or May they came out with it. And as it says, it's a family of hardware, software, and services designed to accelerate business transformations using IoT and AI at the edge. You can check it out on this link, but you can, usually question I get where to get it, go to Microsoft Store to answer immediately. This is how the device looks like. We have one smart board. It's pretty much like Raspberry Pi, for example, but this is a pretty cool case that is used for cooling over here with 2 antennas. We have what comes in the standard kit is a smart camera over here. That's the camera you connect to the module, and you can additionally buy the linear array of microphones, so you can give it some voice commands and such. It can act like any smart home device with voice. You've probably seen many of them, right? And use them. So this Percept Kit is capable of running model on the device, process the data from the camera or from the audio, and only get data points to the cloud. So it's not streaming video to the cloud, which immediately solves, like if you process the videos like this, it immediately solves some problems like GDPR, because data is processed here, it's not stored, we only get the data points out. I see 20 people, right? I can say where they are positioned, but I'm not giving any personal information out of it with use of AI that way. Yeah, and in Azure Portal there is Azure Percept Studio. It's really easy to use it. Basically, one service where you go to deploy models to the device, and you can set up whole device. Microsoft is saying like in 30 minutes, but you can do it even faster. It's really plug and play. You connect it, you go to Studio, prepare some model that is already defined. You can use like models for general object detection. This is a cat, this is a dog. To detect people, to detect products on shelves, or vehicle detection. This is something that comes out of the box. I believe they will extend this with even more models. So just click this, deploy to device, and try it out. You see how it works. You can open the browser and see the detection. If you use the voice assistant templates, there are some for hospitality, healthcare, inventory, automotive. For example, this inventory one will give you options to say to that microphone, okay, remove 5 green boxes from the warehouse, and it will immediately remove them. So you can see how that kind of, how that template works. You can try it out. So getting back to our example of R2D2, we trained it in the custom vision, and we want to go we want to publish it to device. So we go to Percept Studio, And over here, as I said, interface is pretty simple. Like if you are new to AI models, you can quickly create prototype, try the simple applications, or you can do some advanced, open the advanced tool and do something more complicated. Once you add your device, it will be listed under devices. For that device, you can automatically get the address where you can access it like live video feed from the device to see what's happening over there. So over here, you can click your device and you can say, publish my model that I just trained the R2D2 model. And it will look something like this. Over here, it's detecting R2D2 with 70% probability. It was trained with only 100 pictures generated with synthetic data, only synthetic data. So this model never seen the real object. 3D object we had was realistic enough to, for AI to be able to recognize it. Adding more pictures improves the accuracy. And if you automate this process, then 100 pictures is nothing. You can easily upload 10,000 pictures and such. Custom Vision has the API where you can connect directly and send the pictures over there. You can send also the bounding boxes. You calculate from your picture where exactly that R2D2 is. You can send the data immediately, so everything's tagged, everything's automated. That process I showed you in the beginning, you're no more wasting time, right? You can connect it and do it immediately. One thing I'll show you is something I work on in my free time for some 6 months or more, I think. It's one web tool for the synthetic data generation. Project supported by Microsoft for startups. If you have some kind of project, you can apply it over there. You get a lot of free credits. They have 4 different stages, depends like where you are. You can use first 2 stages without registering the company. Then you need to register the company to move on. I think first stage is they give you $1,000 of credits. Second one, 10 times more or something like that. And then it scales up to 150,000 credits that you can use. It's actually really great to try out some project and get some cloud power to build something. And what it is, like a simple web tool where you can actually upload your models and do something like this and connect directly to Custom Vision. One example over here that I use, this is the green turtle. And it's realistic 3D model. It's animated. And you can see over here through the interface how this data will be generated. That's the model. We apply texture to it, basically what I showed you now, how you can do, for example, in a browser and such. You apply different backgrounds, you apply rotation on camera, lightnings, how many pictures you want to generate, and then you integrate directly into Custom Vision, so it sends data over there. Model never seen the real turtle. This is from the Custom Vision interface. So I added few pictures to see, okay, how well it detects. And I was pretty happy with results. This is not using 100 images anymore to to get this accuracy, because like you need a lot of pictures. But imagine that you need to recognize your product and that you need to take 10,000 pictures and then tag each one of them manually. That could be really long process. If you're interested, feel to follow on the LinkedIn for the updates. So that was it from me. Would be nice to hear if you have some questions. As I said, I hope I gave you, like, through this story, from some basic things through a bit of deep dive and showing example how we actually can generate this data, gave you some ideas what you could do, and why, as that Gartner research was showing, why data is really going synthetic way. Like, why are we going to see these examples more and more? Yeah. So, thank you.
So do we have any questions from the audience?
I would, yeah, do I need to repeat because of all I know? Okay, have I use some kind of text kind of input where it would recognize the text and then generate based on that text different objects? I would need like a repository of 3D objects to be able to find them, because programmatically defining an object, that is really hard. Would be maybe possible with that, but this is far stretched, okay? Maybe sometimes in future. If we, for example, take that Nvidia Nerf, which is capable of generating 3D scene from 2D pictures. So maybe if I search for something and pick few pictures from the Google, I could render the scene and use that 3D object into for the generation. But that would require that all pictures are from same object, not really what happens with Google search. So yeah, could be you have some similar. No, I don't know about that. Haven't. It's producing something like that. Yeah.
Based on OpenAI, takes natural language, creates objects.
Ah. Yeah.
Yep, thanks. So for the initial question was not around the 3D objects or 3D synthetic data, but just simple two-dimensional. You just type in as an input green table, and it will generate objects with different types of tables that you can potentially see in IKEA.
Yeah.
And then this data is used in machine learning.
The thing is, we need to recognize the same object, right? So that's what we are trying to do over here. And also, as I said, like focusing is on realistic models. So AI can actually recognize exactly that thing. So if I get many different tables, yeah, okay, I could use it for classification and say, this is a table, right? And this is a chair or whatever. But in object detection, I would aim for some realistic model that I can always recognize, like this is a product. Yeah.
Okay. So synthetic AI is pretty close to the digital twin realm of things. Can you talk about that connection?
Yeah, sure. Like with digital twins, we are making a copy, real-world simulation of what is happening over there. We usually 3D model things to make it visual, even though like Azure digital twins allow us to build like a graph. Okay, we have room here, then we have in room 10 sensors, then that sensor has some values and such. But yeah, aim is to, with digital twin, to understand what's happening in real time. We could easily plug it in. There was a really nice example from Microsoft, now comes to my mind. They build wind turbines, digital twin, right? So we could maybe use that 3D model to generate synthetic data. But the idea with digital twin is also not just to be able to see what's happening right now, but also to be able to run the simulations and predict what will happen in the future. So with windmills, yeah, if wind increases that much or tornado came, like what will happen, how much power we will generate, and things like that, figuring out some preventive maintenance, and yeah. So in that simulation, that data can be used as synthetic data, not for the vision training, but for some other trainings. Yeah.
Yeah, I can just a short story that we had. Azure Skåne had an AI day. Was it 2 years ago, I think? And one of the presenters there, they had made a model in production from cranes that are in building sites, and there was an alerting system in that crane. And they talked about how they made that alerting system. And the most annoying part of that project was taking the pictures. They had to sit in the crane and take 1,000 pictures to be able to train the model to build that alerting system.
Yeah.
So they could have used this solution instead.
Yeah, maybe rendering and using some realistic scene could make it easier. Okay.
How do you handle comparing the actual your synthetic model with a real world model? Do you have some kind of evaluation to see if they're
I did some tests, and it's hard to say, okay, I generate R2D2 like this, I use 100 images, then I take 100 photos of it, or any other object I'm playing with, and results pretty much the same, if this is realistic model, right? If it really represents that. Also comparing to maybe using full 3D scenes as Unity is using, or the Nvidia is using. If you want to build some model for self-driving vehicle and you really want to know that factory, then okay, model that factory, use that, don't use Star Wars background or whatever, right? Then go for it. But for some more general purpose, synthetic data works perfectly.
Okay, if we don't have any more questions, I think it's time to say thank you again. And we will take a short break, and we have the next presentation at 20 past 11.